Well, good evening, everyone, and welcome here to the launch pad and our live countdown to launch coverage of the 69th Electron mission from Rocket Lab. Rocket Lab is officially targeting 11:50 p.m. Eastern Time, 9:50 p.m. Mountain Time here at our TLP Canada studio. Getting used to not saying Space Coast anymore. Getting set up back up here in Canada. We're glad to have you all joining us live here tonight. If you haven't yet, take a moment, engage that like button, share out the stream, invite people to join us as we continue to count down to launch. We will patch Rocket Lab in the next couple of minutes once they go live, but for now, we're going to run through everything we know about today's mission and answer some of your guys' comments and questions. You can send those in the chat by tagging us at the launch pad, and I'll work on answering those live. As always, we get started with where's everyone watching from. We got Crocodile in Germany. Welcome. Great to see you. Denise, Zach, great to hear you. Thanks for saying that. It's good to be back. Getting back into it slowly. Getting set back up here in Canada. Lots of people just tuning in. We got Denise in California. Splurge is in Huntsville. Windbreakers in South Arkansas. We got Lindsay in Tennessee. Great to have you here. We are now counting down about 28 minutes, 40 seconds from now expected liftoff. We've been monitoring the weather as a team, and right now everything is looking good for today. Only a 5% chance of violation for weather. Launch load is begun on the Electron rocket, and the payload is ready for liftoff. The airborne radiosondes, which are on those weather balloons, do show some strong upper level winds, but there's no wind shear to them, which is a good thing to see. So it is likely safe for launch. That's probably where that 5% chance of violation is coming in. We're doing our best to try to expand a little bit more on the weather coverage, give you guys a better idea of these launch criteria. So if there's more things you want to see us add to our coverage that would help make it even better, answer more questions that you have, let us know in the comments. We're writing those down as we work to expand our coverage around the world, but we're glad to have you here. We got Arcad and Fortuna in Toronto. Kells is in New Zealand. Jeff's in South Mississippi. Luis is in New Jersey. Welcome. Rick is still in Tennessee. Dylan is in Pennsylvania. We got Phil in Alabama. Joe's in Virginia. And Big Mike is in the U.S. Welcome. It's great to have you all joining us live here today. And Dogfish, thank you so much for being a suborbital explorer for 17 months. Really appreciate your support there. All of that goes into making it possible for us to expand our team, get better equipment, and grow our coverage to bring you better coverage of everything space from around the world. Now, today's mission is the 69th mission of Electron for Rocket Lab. The mission name is The Harvest Goddess Thrives. On board today, a singular payload heading up to low Earth orbit. The IQPS company manufactured the QPS-SAR 12. These are very small, high-performance SAR satellites that use a lightweight, large, stowable antenna to collect high-resolution images of Earth, even through clouds and adverse weather conditions. The constellation that IQPS is building is set to have 36 satellites capable of monitoring specific fixed points on Earth every 10 minutes. In addition to launching on Electron, the QPS-SAR satellites use Rocket Lab's Motorized Lightband as part of the separation system for the deployment of their satellites in space. Today's payload weighs about 100 kilograms on board, so definitely not anywhere near capacity for Rocket Lab on the Electron. An Electron launch costs about $7.5 million per flight and is able to carry 320 kilograms to low Earth orbit. The Electron rocket stands 1.2 meters, the rocket stands 18 meters tall with a fairing of 1.2 meters diameter and let's try that one more time. It's been a while since I've done one of these Electrons. The rocket stands 18 meters tall. The fairing on the rocket is 4.05 meters, and the fairing diameter is 1.2 meters. We got there in the end. Rocket Lab is a 3-stage launch vehicle that launches with 224 kilonewtons of thrust at liftoff. On your screens, live look at some of the weather satellite images coming in down to New Zealand. The X on the screen, that is X marks the spot. That is where Rocket Lab will be launching from the Mahia Peninsula in New Zealand here today, where Rocket Lab has Electron out on the pad. We're going to switch our screens over to the split screen. Rocket Lab is out on the pad. They'll be getting ready to begin their live coverage right around that 20-minute mark, and once they do, we will listen in to Rocket Lab Mission Control. Matthew, thanks for becoming a member or being a member there for 14 months. Appreciate your support. Kind of boy, can you volume up a bit on your mic? Yes, let me adjust that. I'm not on my good mic here tonight, so bear with me on that. We'll have that back up and running here in the next little bit as we get settled back up here in Canada. But if you guys have questions, you can send those in the chat. Tag me at the Launchpad. We'll work on answering those live here today. Lots of people just jumping in. We got Patrick from tennis. Steven is from Boston. We got Carrie in Bradenton, Florida. Welcome. Also got Joe in Virginia. Phil's in Alabama. Taking a look just at the launch schedule for the week ahead, it's going to be a busy month in August. We're expecting to have an Ariane 6 flight, Starship flight, a Vulcan flight, a Soyuz, possibly a couple other demo flights of other vehicles around the world, and then of course a whole bunch of Falcon 9s. On Thursday, Falcon 9 is going to be launching the second batch of Project Kuiper satellites from Florida. On Saturday, we have a group of Starlink satellites from Vandenberg in California. Sunday, we got more Starlinks launching from Florida, as well as we're expecting possibly a Vulcan launch that day. Next Tuesday, we've got the Ariane 6 flight out of the French Guiana, and so much more happening later this month, including Bandwagon 4, New Star Lima launching on a Falcon 9, Tranche 1 Transport Layer B. We've got the Progress MS-32 crew, IMAP on a Falcon 9, and so much more. It's going to be a busy month, and you'll be able to catch that all live right here on the Launchpad Network. So make sure you take a moment, gauge that subscribe button so you never miss a live launch coverage right here. Glenn A. Zach, have you finished moving? I technically have. I am back at home here in Canada. I do have a 16-foot pod. If you know what those are, they're basically shipping containers, a 16-foot shipping container that is crammed to the fullest. That is making its way from Florida to here. So it takes a few weeks to be driven up and clear customs and all of that. So hoping to have the Florida studio here to be set up by the end of the month, and then we'll set that up in September. Some other stuff will be happening this fall that we'll dive into a little bit later. Some personal projects going on and different things, but won't affect us covering any of these launches. But excited to get the studio set back up here. We have the current one, but we're going to be setting up a much more like what we had in Florida. We'll be setting up here a much more upgraded studio with multiple sets and stuff, so we can bring back the news coverage that we were testing out this spring. Again, apologies that we haven't been able to maintain that over the summer. I really enjoyed doing it, but just with obviously everything that happened through the spring and summer personally, and looking for a couple script writers and editors to join the team to help alleviate some of the pressure on it. It just wasn't possible, so we're looking to bring that back hopefully sometime this fall. If you're interested in joining the crew, we have our applications are open. We are looking for writers as well as video editors to join the volunteer team. Just because it's excuse me, just because it's volunteer now doesn't mean it'll be volunteer forever. We are looking at rolling out hopefully some paid positions next year. So definitely a great time to get on board for a chance to maybe get considered for one of those in the future. But one of our biggest things is we want to grow a team that's really passionate and dedicated to this, not just doing it because it's a paycheck, but because they actually truly love what they're doing. Jake, hi Zach, I saw NASA's posted something about Crew 10. Yes, Crew 10 will be departing the International Space Station We're expecting that to occur anywhere from a week to 10 days. I'll double check to see if we have the Crew 10 farewell. Oh, okay. Tomorrow afternoon, the 1:10 Eastern, the Crew 10 farewell and change of command ceremony will occur on the International Space Station. Thanks for flagging that, Jake. We will try to be able to bring you live coverage of that tomorrow, and then they'll probably depart a couple of days later. Glen A, it's going to be a great month for launches. I'm hoping so. I'm hoping we'll see Starship 10. I can't believe we're saying that already. The 10th flight test of Starship. How incredible. Hopefully we'll see that out on the pad this year, or this month. Let's listen in to Rocket Lab Mission Control.
Crisp afternoon at Launch Complex 1, where Electron is preparing for its latest mission from our private launch site in Mahia, New Zealand. Right now, it is T-minus 19 minutes in the countdown to Electron's 69th launch and our 11th launch of the year, our next in a series of missions for Japan-based constellation operator IQPS. Good afternoon and welcome to today's launch coverage. I'm Sam Peters and along with me is Catherine Chen, and we'll be taking you through the final moments before Electron takes to the skies once again.
Thanks, Sam. It's great to be here for this next Electron mission. Launch preparations are well underway and have gone pretty smoothly throughout the count today. We're tracking no issues with the rocket, the range, or the weather in the lead up to liftoff, and the team is aiming for our launch target right at the top of today's window at 3:45 p.m. local time or 3:45 UTC. Today's launch is the fifth in a series of missions for the Institute of Kyushu Pioneers of Space, or IQPS, to build out their Earth imaging constellation that provides SAR, or synthetic aperture radar imagery.
Now, we've called this one the Harvest Goddess Thrives, named for the satellite onboard Electron that the IQPS team affectionately know as Kushinada-1. This is named after the Japanese harvest goddess, a perfect fit for a satellite designed to help better monitor Japan's agriculture and resources. With 4 successful missions for this constellation flown by Electron already, we are very much looking forward to deploying another IQPS satellite to space for them today.
Now, one of the fun parts of working with IQPS has been coming up with the mission names and patches, with each of the QPS-SAR satellites named after a different Japanese god, or in this case, goddess. Kushinada-1 will be joining its fellow gods launched on the previous Electron missions like Tsukuyomi for the Moon God Awakens back in 2023, and the remaining satellites all launched this year by Electron, Susanoo for the Lightning God Rains, Wadatsumi for the Sea God Seas, and Yamatsumi for the Mountain God Guards. After today's mission, Electron will have deployed 5 of the planned QPS-SAR constellation, with another 3 missions and gods yet to go. It's an honor to be launching the constellation, and we're excited to get another one off the pad today with Kushinada.
Now, the QPS-SAR 12 payload on Electron today is headed to a 575-kilometer orbit at a 42-degree inclination and launching on a southeastern trajectory from Launch Complex 1 over the South Pacific Ocean. Their planned 36-satellite constellation in low Earth orbit is designed to provide near real-time observation of Earth using synthetic aperture radar. Now, SAR cameras are unique in the fact that they can capture images night and day and through cloud cover, which is often a challenge for traditional optical satellites. Let's hear a little more from IQPS about their mission.
are so many great ways SAR technology can be used, and it's awesome to be supporting IQPS to get their constellation deployed as quickly as possible to realize their mission. 4 missions on Electron this year alone, more than any other customer of ours so far in 2025.
And taking a look now at the views of the launch pad, the vehicle's LOX load is underway for today's flight. We time LOX loading as close to launch as we can to keep this high-performance propellant as super chilled as possible. This is usually around negative 183 degrees Celsius or negative 297 Fahrenheit. Propellant load status is one of the critical milestones checked during the go, no-go poll run from Mission Control in the countdown to launch, which is coming up very shortly at T-minus 12 minutes to liftoff.
That's right. Soon we'll hear our launch director for today's mission, Julia Wembacher, call out to all operators for an update across all monitored systems, as well as a check-in on whether range and weather conditions are expected to be good or go right at our T0 liftoff target. Let's listen in now to hear how we're tracking for an on-time liftoff today.
If you see in the top left of your screen, you will see the launch director has paused the time at T-minus 11 minutes. We'll throw it back to Mission Control until we hear more. And while we wait, we want to provide you an exciting update on one of our spacecraft missions. Last year, we built 2 identical spacecraft for NASA and UC Berkeley's Space Sciences Laboratory as part of their Escapade mission. Now, Escapade stands for Escape and Plasma Acceleration and Dynamics Explorers. These 2 spacecraft, named Blue and Gold after UC Berkeley's school colors, will go to Mars to investigate Mars's hybrid magnetosphere.
Now, Escapade is part of NASA's Small Innovative Missions for Planetary Exploration program, which really emphasizes getting high-quality science done with smaller, more agile missions.
And by flying these twin spacecraft in tandem, they'll be able to capture a much more comprehensive picture of the magnetic fields and plasma dynamics around Mars, measuring things like the energy and speed of particles being lost from the atmosphere, and generally getting a better understanding of how the planet's climate has changed over time.
Our Space Systems team is performing routine maintenance and tests, preparing the twins for their journey back to Florida for launch. It will no doubt be an extremely proud moment when we get to send these 2 to space. Stay tuned for more updates on this incredibly exciting mission.
And if you've ever wondered how we've been able to make such massive strides, anyone who works here at Rocket Lab will tell you the same thing. It's because of the incredibly talented and dedicated people who work here.
And we're always looking for new talent to join the team, both on the launch side of the business as well as across our Space Systems division that designs, builds, tests, and operates spacecraft. Let's take a look at this breakdown of what it's like to work in Space Systems here at Rocket Lab.
Really cool missions in the process. So whether you're straight out of college or a vet with 20 years of experience, everyone works together to tackle the same problems and advance the same mission. And if you're interested in joining them, there's likely a role open for you. Check them out on our website, rocketlabcorp.com. All right, the team have identified the reason for the hold and the clock has been reset at T-minus 12 minutes. Standing by now for the go, no-go poll in mission control shortly.
And to all operators, LD and mission code, just a heads up, we will be picking a new T0. We are looking at 10 past 4 local time. So I'm repeating, we will resume the count and we are looking at a T0 of 10 past 4 local time. And to all operators, LV and mission code, I can confirm I'm actively monitoring mission code, LV code and safety net.
All right, we just heard from the launch director. The count has resumed and we are at T-minus 15 minutes in the count.
And to all operators, LD and mission code, we are proceeding now with the go-no-go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Recon.
Recon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
And LD sub.
LD sub is go.
The go-no-go sequence is complete. We are currently T-minus 11 minutes and 16 seconds and counting. We go for terminal count auto sequence at T-minus 10 minutes. From this time, the 3-bed procedure is in effect.
And that's exactly what we want to hear. We are go across the board for Electron's 69th launch. No issues with the rocket or pad systems, the payload is healthy, and the weather is cooperating for today's launch. We are now at T-minus 10 minutes to liftoff, and things are looking appropriately green for the Harvest Goddess. While we wait to hear an update from Mission Control about today's launch from LC-1, over on the east coast of Virginia, our third launch site, Launch Complex 3, is progressing smoothly.
We're almost ready to cut the ribbon on the launch site for our new reusable rocket Neutron, our dedicated launch, test and landing site for future missions. Here's more.
LD avionics on mission card.
Avionics LD.
Avionics terminal checks complete.
Copy, thank
LD GC on mission cord.
GCLD.
LD, the hold down mechanisms are armed and the strong back is retracted for flight.
Copy, thank you.
Okay, it is now T minus 4 minutes on the countdown clock to launch as we approach liftoff time here in New Zealand. At around T minus 2 minutes, Electron's autonomous flight computer will take over the final sequence of launch preparations. Shortly after that 2-minute mark, we should hear the call that LOX loading is complete, which means that Electron is fully fueled for launch. The next gate after is the signal that the first and second stages are pressurized for launch. And after that, we wait for the 10-second countdown to liftoff run by our launch director. Let's listen in to Mission Control now for these final steps in the sequence. We'll be back with you after liftoff. Go Electron.
Understood, thank you, GC. To all operators, LD admission code. From now on, there should be no red flags on the critical LCCs. VCON LD mission code.
LD VCOM.
Lock the auto sequence and confirm.
Auto sequence is locked.
And VCON please confirm all flight computer ASCOs are green.
All ASCOs are green.
To all operators, we are go for auto sequence start at T minus 2 minutes. LDs go for launch.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
We are T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Beginning pitch over.
Stage 1 propulsion nominal.
The Harvest Goddess is on her way to space for IQPS. Electron has launched cleanly off the pad at Launch Complex 1 and is now coming up against 700 kilometers per hour. In just a second, we should hear from our operators that Electron has reached Max Q, which is the point in the flight when Electron is experiencing maximum aerodynamic pressure.
Vehicle is
It's the
supersonic,
first
approaching Max
milestone
Q.
as we listen out for the launch. So let's bring up the audio channels now from MCC.
Cleared Max Q.
That was a nice, clean
HVP
pass through Max Q
discharge
for Electron, and we are now about a minute or so away from staging and main engine cutoff on the first stage. Now, what should happen next is that all 9 Rutherford engines on the bottom of stage 1 will shut down as planned, and just a couple of seconds or so before the
Stage
second
1
stage
guidance
is
is
released
nominal.
from its separation locks. Once we are clear of the first stage,
with the
the
channel
Rutherford
station.
engine on stage 2 will ignite to propel Electron and IQPS onward to our target altitude for this mission. Let's keep an eye out now for the view across both stages as those
Stage
events
1
take
propulsion
place.
holding nominal. Stand by for MECO in roughly 30 seconds.
$15 seconds to staging. Entered burnout detect mode.
MECO confirmed.
Stage separation complete.
Stage 2 ignition confirmed.
A clean separation from the first stage as planned, and a beautiful start up there by the Rutherford engine on the second stage. That second stage's velocity is now at more than 8,000 kilometers an hour with an altitude of 95 kilometers after that separation event. Next up will be fairing separation for Electron when the rocket's nose cone halves split and fall away to expose the Kushinada payload to space for the first time.
Fairing jettison confirmed.
And there you have it. Electron's
Stage 2
two
guidance
fairing
is nominal.
halves have jettisoned from Electron, and on your screen you'll see the Harvest
Stage 2
Goddess
propulsion
safely
nominal.
attached to the kick stage and ready to make her debut on orbit. Taking a look now at the propulsion monitoring camera at the bottom of stage 2 shows that
HVP
Rutherford is
discharge
continuing
holding
nominally
nominal.
since engine startup, which happened just a few moments ago.
We have another 5 minutes to go for the second stage engine burn until the next separation event. This Rutherford engine's performance can reach up to 5,800 pounds of force in the vacuum conditions of space, with a specific impulse of 343 seconds. Now, specific impulse is a measure of performance in telling us how efficient an engine can be. One of the pretty special things about both our sea level and vacuum optimized Rutherford engines is that they're actually battery powered. The propellant pumps on these engines are driven by brushless DC motors powered by batteries. Now, since the amount of time the second stage engine needs to run is longer than the capacity of the first battery packs, Electron needs to perform a power switch over to a fresh set of batteries to keep the engine running. The flight computer does this while the engine is still burning hot. That's why we call it the battery hot swap. In a few moments, you should hear that call out from our launch operators, and if you keep an eye out on your screen, you should see those batteries eject in the next few moments.
HVB discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down. Battery jettison confirmed.
Confirm hot swap successful.
Nice and clean with that
Stage
battery
two
hot
propulsion
swap
holding
there,
nominal.
and one of the final launch milestones completed on Electron for its 69th mission to space. We are cruising along now at 15,000 kilometers an hour at 220 kilometers in altitude. Just two more key events remain for this first stage of the mission. That is SECO, or second engine cutoff, followed by stage separation, where Electron's kick stage separates from the second stage and gets ready to deploy the payload into orbit.
Nominal.
We're getting some stunning views of Earth from space from our onboard cameras. We touched on it a little bit at the start of the show, but right now Electron is running fully autonomously. What that means is our extremely talented GNC engineers have completed all the analysis to determine how to get to the specific place in orbit, and right now Electron's flight computer is running its algorithm in real time to fine-tune its performance and land Kushinada 1 on its final deployment orbit.
Right, so we are approaching 8 minutes into flight, and you can see on the right of your screen, Electron's second stage has around 13% of propellant remaining. Much like the first stage, there's no sense in carrying dead mass to orbit, so shortly we will separate the kick stage and payload from stage 2. We are soaring now past 22,000 kilometers per hour at an altitude of 230 kilometers above Earth.
With less than a minute left on this engine burn, we're approaching SECO. The engine on your screen there will power down and shut off just a moment before the kick stage is separated into a transfer orbit. Now, it may sound simple, but this is a very precise maneuver, and it's important that the kick stage is exactly where it needs to be for the next phase of the mission. Let's listen back into mission control for that SECO call and stage separation confirmation.
SECO confirmed.
Nominal transfer orbit achieved. Stage separation confirmed.
With that Rutherford engine cold, we have heard confirmation from Mission Control that SECO has been cleared, and we've had a clean separation of the kick stage with the QPS-SAR 12 to a nominal transfer orbit. What that means is that the Harvest Goddess and the kick stage are on the planned trajectory to transition from this initial elliptical orbit to its final desired circular orbit at 575 kilometers. This takes about 40 minutes or so to complete before the kick stage ignites our Curie engine to perform a circularization burn, landing us in our 575 by 575 kilometer orbit.
We'll be back with you for those final moments of the mission, but for now, you can follow the path of the Harvest Goddess in real time with our animated tracking graphic. Hello and welcome back to the broadcast for our 69th Electron mission, The Harvest Goddess Thrives for IQPS. Now, if you missed Liftoff 52 minutes ago, we had a beautiful start from Launch Complex 1 in New Zealand that set Electron on a clean run through the usual launch milestones like MECO, Stage 1 separation, battery hot swap, SECO, and kick stage separation.
That's right. And just a few minutes ago, the kick stage moved out of its transfer orbit with a course correction to a circular trajectory around Earth. This moved it into the exact position it needs to be for payload deployment to a 575-kilometer altitude, where the Harvest Goddess will join the rest of IQPS-SAR satellites in its constellation. Now, all was nominal there for Curie's startup and shutdown, and now we are just moments away from the QPS-SAR 12 satellites deployment. Let's listen back into mission control for the final moment of the mission.
Payload deployment QPS-SAR 12 confirmed.